Hi guys, we're going to continue on with our chemical reactions and engineering design lab this week. Where we left off last week was after having done the first little mini lab, and I think it was on the 5th page of our, right here, our 5th page of our lab sheets. Okay, so what we discovered was that when you add calcium chloride to water, it's an exothermic reaction. And so it releases, or one of the products of the reaction is heat energy. Okay? And we also discovered that when you add baking soda to that solution after it's been heated up, it will actually reduce the temperature. Okay, so leading to a little bit of cooling. What we did not talk about on Friday is another thing that happens here. Okay, so let me I am going to make this a full screen. We're going to talk about it. I'm just going to pour a little bit of water into a cup. Okay, a little bit of water into a cup. And I am going to add some calcium chloride to it. Add some calcium chloride. We'll do a teaspoon of calcium chloride. Okay. And we will take the temperature here. See what is happening. It was about 22 degrees when I started. I put quite a bit of calcium chloride in there, 1 teaspoon. I think in lab we only used a half teaspoon. So it's going to get a little warmer with the more you put in, and I can actually feel the heat on the bottom of the cup. Again, this is an exothermic reaction, and so the temperature is right now inching up to 35 degrees Celsius. And it's kind of leveling off there, 35 degrees Celsius. Okay. When we add baking soda to this, just like we did on Friday, you're going to notice that the temperature is going to drop, right? So I'll do that. I'll add a little bit of baking soda to it. And I want you to watch to see what else happens here. I'm going to turn the thermometer so I can actually see it. Yeah, the temperature is at 35 degrees Celsius. So when I put this in, something else happens. Bubbles, right? A gas is being produced. Well, how could that possibly be of benefit to us? Temperature is dropping rapidly. It's now right about 20 degrees. How could bubbles be of benefit to us? We want to get a specific temperature. But remember, we're making an egg incubator. So we have to be able to pick up an egg and safely transport it to another area. You guys are going to be doing this lab inside of a baggie. Okay, so this could be, if we zip this closed, it will be a closed system. You'll have we'll put a twist tie in between here. Okay, so your water will be on one side, your chemicals will be on the other, and then when we're ready for them to react, we take the twist tie off and they mix. If this bag is sealed, how could a gas being released be of benefit to you when you are trying to safely secure an egg and safely transport it? Think about that with your fellow students today. Okay, let me go back to the lab sheet. So I bring that up because on the bottom here it says, should we use baking soda in the design of a portable reptile egg incubator? Well, some advantages would be what? Baking soda is pretty cheap, right? So that would be an advantage. Disadvantage might be it might make it too cold. We have a specific temperature that we want to target. Okay, so that could be a disadvantage. An advantage, I'll give you a hint, the bubbles could be an advantage if you're using a closed baggie. What is that advantage? All right. So discuss this with your classmates and see if you can come up with some more detailed advantages and disadvantages of using this fairly inexpensive chemical right here. Okay, we are going to back up a little bit to, we started out talking about the criteria and the constraints. You guys are going to be getting a specific list of materials to make your egg incubators. Okay, everybody's going to get the same amount of materials, and you'll find out what those are on Tuesday. All right. It says, think back to the story about transporting reptile eggs from a construction site to a reptile conservation center. Read the text message from one of the construction workers in the illustration on the left. Okay, so it says, look what I found. Can you pick them up this afternoon? All right, so we're going to take a look at the reptile egg identification chart on the next page to answer the following question. Does this egg belong to a snake, turtle, or lizard? All right, so we've got to take a good look at these eggs right here. It looks like it is 1, 2, 3, 4, 5, 6 centimeters long. They look smooth, and they look like they are above ground. Okay, so we're going to go to this side right here, and we're going to see if we can find which eggs they are. So we said it was 6 centimeters. These are far too small. These ones look like they've been dug in and they're actually laid and buried. These ones look about 6 centimeters long and above the ground. Okay. So snake eggs are found in a hidden location on the top of the soil, dried leaves or mulch. Snake eggs are oblong and irregularly shaped. Their total length is 4 to 10 centimeters, and the incubation temperature needs to be between 28 and 32 degrees. Okay, let's go back up here. So we are going to say right here for number 4A, do the eggs belong to a snake, a turtle, or a lizard? Okay, so which one did you think that they belong to? And what characteristics help you identify those eggs? The next one, as you design your temporary portable reptile egg incubator, you will need to consider the ideal temperature the reptile eggs need. What temperature range should you aim for when you mix calcium chloride, baking soda, and water? Okay, so I want you to write that down here too. What temperature are you aiming for? All right. We are going to pick up the next day with this last little lab here. Okay, we're going to be combining some different chemicals to try to meet that target temperature. We are going to find kind of a perfect recipe for that temperature. We're going to test it out in a closed, sealed bag and see what happens with that. And then you guys are going to get some time to actually build a little portable egg rescue incubator, and you'll mix your chemicals and we will try it out and see if it all works. Not with real eggs, but with little plastic Easter eggs. Okay? We will talk soon.